So now let's look how to go the other way. Now let's convert some of our numbers to Babylonian numbers and symbols. So here it says convert to Babylonian numerals 6,432. I always make a table. I find it keeps me neat and organized. And I'm going to do basically the same thing with this table that I did as my first step in the last problem that we looked at. I'm going to write my powers of 60. So that's the first thing I'm going to do. So here's my 60 to the 0 power, my 60 to the first power, which is of course 60, my 60 squared power, which is 3,600, and my 60 cubed power, which is 216,000. I don't know why this parenthesis didn't show up. That's strange. Okay, so now I need to look at my number, 6,432, and I basically need to decide how high up in this chart I need to go. So if I look at my 60 cubed, that has a value of 216,000. That is way too big, right? I'm only dealing with 6,000, not 216,000. I'm nowhere near that. So I'm not in this place. I'm not in the 60 cubed place value. So now I'm going to look at my next place value, 60 squared, which is 3,600. That's reasonable, right? I can fit 3,600 in here. So the question becomes, well, how many 3,600s can I fit in here? It sort of becomes a problem of division. So if I have one 3,600, that's 3,600. If I have two 3,600s, that's 7,200, which is too high. I didn't get to 7,000 here. So I only need one of these. So if I think about it as division, if I take 6,432 and I divide it by 3,600, right? I'm trying to figure out how many 3,600s will fit in there. I'm going to get 1 point something. So that means I need one 3,600. So I put my 1 here. And I know that 1 times 3,600 is 3,600. So if I started with 6,432 and I've used 3,600, how much do I have left of this? Again, this is sort of like long division, right? So I'm subtracting off that 3,600 that I've used, and that leaves me with 2,832. So now I need to say to myself, okay, I have 2,832. I'm going to move into my next place value, which is 60 to the first, a value of 60. How many 60s can I fit in 2,832? Well, if I take 2,832 and divide it by 60, I get 47 point something, 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 something. Okay, so that means I can fit 47 60s into my 2,832. So if I have 47 60s, how much have I used? 47 times 60 is 2,820. I started with 2,832. I used 2,820. How much do I have left? I have 12, which means I have 12 left in my units place, okay? So I have 12 in my units place, 47 in my 60 to the first, and 1 in my 60 squareds, okay? So now I need to just make sure that I did indeed do all my math correctly. So you always take these numbers and add them together, okay? And you should get back your original number. So if I add 3,600 plus 2,820 plus 12, I do indeed get 6,432. So my math is correct. And now I need to take each of my place values and convert them into Babylonian symbols. So in my first place value, I had 12, right? So to write 12 in Babylonian, I need one of those little left arrows and 2 upside down triangles, 10, 11, 12. Okay, I have 47 in my second place value, so I need 4 of the arrows and 7 of the triangles, 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, and I have 1 in my last place value, so just one little upside down triangle. So I know it looks sort of funny to see like 12 in a place value, because for us, once we get past 9, we make that exchange for, like, say we had 12 units. That would never be okay in base 10. We would exchange 10 of them for a 10 strip, and then we'd keep those 2 units, right? But remember, the Babylonian system is base 60, which means you can have up to 59 in any of your place values, right? So for us to have 12 and 47, that's no problem in Babylonian, because we can have up to 59. We don't exchange until we get to 60 in Babylonian, right? So it looks really funny for us just because we have a base 10 brain, because it's what we've known our whole lives. but it's totally fine in Babylonian, okay? So now I want you guys to try one of these on your own. You're going to take a number and you're going to convert it to Babylonian. Start by making your table with your powers of 60, right? Write out the values. You should always do that no matter what. It's super helpful. And then figure out how many of each you need. So pause the video. You're going to convert 3,891 to Babylonian. Right? Really pause it and really at least try, at least fill out the table and see if you can come up with how many of each. Okay? All right, so hopefully you've paused it. So I'm going to fill out our table. 60 to the 0 has a value of 1. 60 to the first has a value of 60. 60 squared has a value of 3,600. Again, that parenthesis didn't show up. And 60 cubed has a value of 216,000. So I'm going to look at 3,891 and I'm going to say to myself, okay, how many, well, first, I'm going to say, hold the phone. 216,000, that's way too big, right? So I'm going to be dealing with, starting with the 60 squared place value because 3,600 is not too big. So now I'm going to look at my 3,600 and I'm going to say, how many 3,600s can I fit in 3,891? Well, I know I can fit 1 in there, right? So if I divide 3,891 by 3,600, I get 1 point something, which means I can fit 1 3,600 in there. Okay, 1 times 3,600 is 3,600. So if I start with 3,891 and I use 3,600, how much do I have left? 291. So now I need to figure out how many 60s can I fit into 291. So if I divide 291 by 60, I get 4 point something, which means I can fit 4 of those in there. 4 times 60 is 240. I started with 291. I've used 240, so I'm going to subtract to see how many I have left. I have 51 left, which means I have 51 in the units place. And that's totally fine, because remember, in any place value, I can have up to 59 before I have to make an exchange. So I should always add these numbers up to make sure that I get back my original. So if I add 3,600 plus 240 plus 51, do that right here, I do indeed get 3,891. And now I just need to write the symbols. So in my units place, I have 51, which will be 5 of those arrows and 1 upside down triangle. In my next place value, I have 240, or excuse me, I have 4. Silly me. I have 4, so that's 4 upside down triangles. And in my last place value, I have 1. So I just need 1 upside down triangle. So guys, please practice, 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 and reach out to me if you have any questions at all. Come to my office hours, reach out, send me a message. If you need to, you can email me. Whatever you need to do, just reach out. Let me know if you have a question. I am more than happy to help you. This is tough at first, and it does take a lot of practice to get used to it. So please reach out. I am here, and I am happy to help always, always, always. All right? So let me know what questions you have, and make sure you practice this. Okay, bye.